For centuries, we've built a story of the cosmos, a universe born in a singular moment, expanding into stars, galaxies, and us, creatures bold enough to name its laws: gravity, electromagnetism, the strong and weak forces. We wove them into a tapestry of order, a framework so precise it predicted the orbits of planets and the decay of atoms. But now that tapestry is fraying. Observations at the smallest scales, where particles flicker in and out of existence, are whispering something unsettling. The constants we held sacred, the speed of light, the strength of gravity, might not be constant at all. They might shift, subtly, across realms we cannot see. A Nobel laureate, whose work once anchored our understanding of cosmic forces, has voiced a possibility that feels like betrayal. What if the universe we've studied is just one layer, one bubble in a froth of realities? What if the rules we've written apply only here, in this tiny pocket, and beyond it lies a multiverse, a vast, untamed wilderness where our physics is but a whisper? The evidence is mounting, and it's not just theoretical. Particle accelerators, those colossal machines that smash the building blocks of reality, are finding anomalies. Neutrinos, ghostly particles that slip through matter like shadows, are behaving in ways our models can't predict. They oscillate, too fast, too strangely, as if tuned to a rhythm from another realm. At the Large Hadron Collider, collisions are producing energy signatures that don't align with the standard model, the bedrock of particle physics. These aren't errors, they're patterns, hints of something larger, something that doesn't obey our rules. And it's not just particles. Cosmic rays, those high-energy travelers from the depths of space, are arriving with energies that defy explanation. They suggest interactions beyond our universe, collisions in a reality where the laws we know are irrelevant. This isn't a glitch. It's a signal that our universe might be one of many, each with its own physics, its own time, its own story. The idea of a multiverse isn't new. It's haunted the edges of physics for decades, a speculative ghost born from quantum mechanics and string theory. But now, it's stepping into the light. The mathematics of quantum fields, the equations that describe the dance of particles, suggest multiple solutions, each a possible universe with its own set of rules. String theory, with its vibrating threads of energy, predicts not one universe but trillions, each tuned to a different cosmic frequency. For years, we dismissed these ideas as untestable, elegant fantasies beyond the reach of experiment. But the anomalies are piling up. The universe is speaking, and it's not speaking our language. A Nobel laureate, whose work helped define the forces that hold reality together, now warns that these discrepancies aren't noise. They're evidence. Evidence that our universe might be a single note in a symphony we can't hear, a fleeting bubble in a cosmic foam where other realities bubble and burst. What does it mean to live in a multiverse? If our universe is just one of many, then everything we've measured, every star, every atom, every heartbeat, is local, temporary, a fleeting arrangement of matter in one corner of infinity. The constants we've calculated, the laws we've written, might hold only here, in this fragile bubble. Beyond it, gravity might weaken or reverse. Light might bend in ways we can't imagine. Time itself might flow backward or not at all. The implications are dizzying. Our physics, our science, our very existence might be an exception, not a rule. And yet, there's a strange beauty in this. If the multiverse is real, then every possibility exists somewhere. Every version of reality, every path not taken, every dream unfulfilled might play out in a universe we'll never see. But it also means we're smaller than we thought. Our cosmos, once the grand stage of existence, might be a speck in an infinite sea. The experiments are pushing us further. At the quantum level, entanglement, where particles share a connection across vast distances, hints at something deeper. Entangled particles don't just communicate, they seem to share a reality that transcends space and time. Some physicists now propose that entanglement could be a bridge, a thread connecting our universe to others. If true, every entangled particle might be a portal, a glimpse into a reality where the rules are different, and it's not just theory. Quantum computers, those strange machines that harness the uncertainty of the subatomic world, are revealing behaviors that don't fit our models. They process information in ways that suggest parallel realities, calculations unfolding in realms we can't touch. These aren't machines breaking the rules. They're showing us that the rules were never universal to begin with. The cosmos is whispering, and we're struggling to listen. Telescopes peering into the deepest reaches of space are finding galaxies that don't align with our timelines, structures too massive, too early, as if they were born in a universe with different laws. These aren't just cosmic oddities, they're clues that our reality might be one of many, each with its own history, its own physics. The cosmic microwave background, the faint echo of the universe's birth, carries subtle irregularities, patterns that some physicists argue could be imprints of other universes brushing against our own. These aren't fantasies, they're measurements, data that refuse to fit the story we've told ourselves. And the Nobel laureate's warning cuts deeper because of it. If these anomalies hold, if they're not errors or illusions, then our universe isn't the whole story. It's a chapter, a fragment, a fleeting moment in something far larger. This revelation forces us to confront time itself. We've always seen time as linear, a river flowing from past to future. But in a multiverse, time might be a mirage. Each universe could have its own clock, its own rhythm. What we call the Big Bang might not be a beginning, but a transition, a moment when our bubble split from another, carrying its own slice of time. Some theories suggest our universe is cyclic, collapsing and reborn in an endless loop. Others propose a quantum sea, where universes bubble up and vanish like foam on a wave. In these models, time isn't universal. It's local, relative, a property of the bubble we happen to inhabit. And if that's true, then our sense of history, of cause and effect, is just a story we've told ourselves to make sense of a cosmos that doesn't care about our narratives. The emotional weight of this is overwhelming. We've spent millennia believing we were at the center of creation, that the universe was built for us to understand. Now we face the possibility that we're incidental, a fleeting spark in an infinite fire. But there's awe in this humility. If the multiverse is real, then the cosmos is more creative, more boundless than we ever dared imagine. Every equation we've written, every law we've discovered is a testament to our hunger to understand. And yet the universe doesn't owe us answers. It doesn't owe us simplicity. It exists, vast and indifferent, a tapestry of realities woven from threads we'll never fully grasp. The Nobel laureate's confession isn't a surrender, it's a challenge, a call to let go of certainty and embrace the unknown. The evidence keeps coming. Dark energy, the mysterious force driving the universe's accelerating expansion, doesn't behave as we expect. Its strength varies in ways our models can't explain, as if tuned to a different reality. Dark matter, the invisible scaffolding of galaxies, shows inconsistencies, clumping in ways that defy our predictions. These aren't just gaps in our knowledge, they're hints that our universe might be interacting with others, its boundaries porous, its laws influenced by realities we can't see. Some physicists now propose that dark energy and dark matter aren't substances but effects, ripples from neighboring universes pressing against our own. If true, then every galaxy, every star is shaped not just by our physics, but by the unseen dance of countless realities. The philosophical implications are staggering. If our universe is one of many, then what is reality? Is it the sum of all universes, each with its own truths? Or is it just the one we can measure, the one we call home? The multiverse challenges not just science, but meaning itself. If every possibility exists somewhere, then our choices, our lives, might be echoes of other versions playing out in parallel. A universe where gravity is weaker, where stars burn colder, where life never formed, or where it flourished in ways we can't imagine. The Nobel laureate's words linger like a warning. We've built our science on the assumption that our universe is the only one. But what if it's not? What if we're just one story among infinite others? The technology is catching up to the questions. New experiments are being designed, detectors to capture cosmic rays with unprecedented precision, telescopes to map the cosmic microwave background down to its finest ripples, quantum computers to simulate realities we can't yet observe. These tools aren't just extending our reach. They're rewriting what we believe is possible. They're showing us that the universe, or universes, might be more complex, more interconnected than we ever dreamed. And yet, the more we learn, the stranger it gets. Each discovery pulls us deeper into a cosmos that doesn't fit our maps, a reality that refuses to be tamed. We stand at the edge of a precipice, staring into a void that might not be empty, but alive with possibilities we can't yet name. This isn't the end of science. It's the beginning of something new. The Nobel laureate's confession isn't a defeat, but a doorway. A reminder that the universe has always been bigger than our stories. We thought we knew reality, its laws, its boundaries, its beginning. But now, we see the cracks, the anomalies that don't fit, the signals that hint at something more. We're not just rewriting equations, we're rethinking what it means to exist. The universe we've called ours might be one of countless others, each a world unto itself, each a story we'll never fully know. And in that vastness, there's terror and wonder. Terror that we're smaller than we thought. Wonder that the cosmos is grander than we dared believe. So we stand here, on the edge of the known, peering into the infinite. The universe doesn't owe us clarity, it doesn't owe us a single truth, but it offers something greater, mystery, a challenge, to keep asking, to keep searching, to keep reaching for the light of other realities. The Nobel laureate's words echo in the silence, a call to let go of what we think we know and embrace what we don't. The universe isn't ours anymore. Maybe it never was. But in that loss, we find something profound, a cosmos alive with possibility, a reality that dares us to dream beyond the stars. And as we stare into that infinite unknown, one truth remains. The journey has just begun.